Morning, kids, again. I'm going to go ahead and complete the rest of this day's stuff. I'm going to go through the actual lecture, so let's go ahead and get started. So let's talk about a circle. And let's talk about something that you guys may have already seen before or something like that. Let's talk about pie charts. You guys have already seen pie charts, and you probably already know how to build one. But let's go ahead and go over the concept real quick. Now, when we're building a pie chart, usually we go ahead and have certain angles according to the proportions of population. So when we do a sample, say for instance, we go ahead and take a survey of 100 people. And we ask them a couple questions. Do you like pizza? Or do you like burgers? Or do you like other stuff? Okay, maybe sushi or something like that. And the group of people that said that they like pizza is going to be about, I don't know, let's go ahead and make up some numbers. About 70 people out of the 100 said they like pizza over burgers or anything else. And let's see, about 20 people said that they prefer burgers. Well, that leaves 5 other people that went ahead and said, oh, we don't like either one of those. We're going to eat something else. We don't want pizza nor burgers. Okay, so we have all that. So from there, we can go ahead and build on percentages based off of this. So 70 out of 100, so that's 70 divided by 100, so that's 0.7, so that's going to be 70%. Made it real easy on myself because, sometimes you just don't want to work that hard. And so 20 of 100, well, that's 20%. And then, of course, 5 out of 100, so it's 5 divided by 100, so it's just 0.05. And so that's 5%. Okay, so we have those numbers. And so when we come to a pie chart, we have to decide, well, how do we go ahead and divide this up? And so we're going to base this off of the angles. So if we say 70%, well, that's going to be 70% of 360. So basically right here, we're going to take 0.70 times 360 degrees. So just doing that right here, 360 times times 0.70 is 252 degrees. So that's 252 degrees. And then, of course, 0.2 times 360 also. So it's going to be 360 times 0.2, which is 72 degrees. Very acute angle. Then, of course, 5 degrees, well, it's going to be 360 times 0.05. If you don't know how to go ahead and change a percentage into a decimal, guys, you better learn. And I think most people do. 0.05 times 360, well, that's going to be 18 degrees. So when we go ahead and divide this up, I'm going to start with this guy, so that's 72 degrees. So we're going to start here from the middle. And we actually measure the angle right here. So let's see, that's a little bit less than 90 degrees. So this right here is approximately 72 degrees. The next one, I'm going to do the 18 degrees. Well, the 18 is going to be just that little small angle right here. So that's 18 degrees. And then, of course, the rest of this angle right here is that big whopping 252 degrees. And so, of course, with the pie chart, we go ahead and highlight these areas in different colors. So this was the pizza group. This was the burger group. And this was the other. Now, when we're talking about arc length and sector areas, we do almost the same thing, but we're going to be basing this off of the angle, and that's going to give us a portion. So let's go ahead and move to another one. I'll go ahead and show you this. So what we're doing today is we're going to go ahead and take these right here. We have a central angle that radiates from the center, you guys, or it could be almost anything. We're just going to start out with something simple. Say that this is 60 degrees. Well, in that right there, we're going to ask, okay, what portion of the circumference is that? So we're going to actually have to use circumference. You guys can do that. So that gives us the entire length of this entire circle. So that's going to be either 2 pi r, which we're going to use mostly today, and also we can also use pi d, because 2 times r is technically the diameter. So say for instance this has a degree measure of, let's go ahead and come up with something easy, something like 10. And we have 60 degrees on there. So let's see, we're going to go ahead and do this real quick. So the measure from here to here, we're actually going to go ahead and get the measure of this. That's going to be the arc length. That's equal to the portion right here. So we're going to get this right here. So this is 60 degrees. So what percentage of 60 is that of the 360? So we have 60 divided by 360. So that's how we're going to go ahead and do this. So first off, we start out with the portion right here. So it's 60 divided by 360. Then we have the actual circumference of the circle, which we have the radius. So it's going to be 2 pi times 10. So let me see, 60 divided by 360. So what portion is that? So 60 divided by 360. That's 1/6 of the so we're talking about 1/6 of the circumference here. And this is going to be 2 times 10, which is going to be 20 pi. And we're going to do a little bit of work right here with simplifying the fraction. So 20 times 1, of course, was whatever. So let's see, we have, this is 2 times 10, and this is 2 times 3. So we get 10 on top times pi divided by 3. This is our exact answer. This is exact answer. This is for example, but we also have approximates here. So that's going to be, let's see, control divide. So let's see, 10 divided by 3. And we're going to be multiplying by pi. Whoops. What happened to my numbers? They all disappeared. So let's do that again. So let's see, 10, 3. Nah, I see what happened. I'm going to go ahead and do that. I do not know why it does that. Okay. 10 pi. So it's 10.47. So 10.47. And that's going to be our answer in approximate terms. And if they tell you by the nearest tenth, that's going to be 10.5. Okay, so here's the actual formula for this. Whoops, why did it do that? I have no idea. So we have that angle. I'm going to erase that. Okay, so we have all that. So talking about this particular problem, we're going to be using this this particular formula. We have the angle that they give us divided by 360 times 2 pi r. Okay. So let's see, we have 300 right here. So 300 minus 360 gives us 60 degrees. So let's see, that's going to be 60 divided by 360 times 2 times pi times 3. Okay, so let me see. Remember, this is 1 over 6, and this is 6 pi, and 6 and 6 simplify to 1, so we're left with pi. So that's our answer. So we have pi as our exact answer, and our approximate answer is going to be 3.1416. And of course, that's a rounded number. Okay, and it doesn't say to the nearest tenth or anything, so we're not going to even worry about that. Okay, so that's about it on that. I'm going to go to the next one. So right here, now we're going to be talking about sectors. So we have this again. Let me get the highlighter. So we're going to be talking about a sector. Sectors are basically the area of this slice. Now, I know that we talked about slices like in pizza and everything, but when we're talking about this in geometry, we're talking about sectors. So almost like the same thing. It's going to be dependent on whatever this angle is. I'm going to call that theta. So it's theta divided by 360 times the area of a circle. So area of a circle is equal to pi r squared. Boy came home one day, told his dad, "We learned something new in school today, pi r squared, Dad." And the father retorted, "No, son, pi r round." Okay, well, if you guys get that joke, that's okay. All right, so we have pi r squared here, so that's going to be how we do this particular part of the section. So we have this right here. So basically they talk about this as a slice, just like I said. Remember, this is the actual formula, so you can go ahead and use that for reference. So find the area of the sector below. So we have the arc right here, which is the same as the central angle, so it's going to be 20 divided by 360 times pi times 3 squared, because that's what our r is. So this simplifies to 1 over 18 times 9 pi. 1 over 18 simplifies to 1/2 pi. So that's 1/2 pi units squared. And if I do the approximate, that's going to be 1 divided by 2 times pi. So if I do that, I'm going to get my pi. I do not know why it does that. Acts like a troubled child on crack. Alright, so 1.57 squared. Alright. So we're going to find the exact area and all that of this one. Just to go ahead and do this real quick. So we're going to have two parts to this particular problem. So we want the exact length of AB and then the sector area. So we have, let's see, 210. So let's see, this is going to be 360. We're going to subtract that to get this arc, this angle right here. So that's going to be 150. So it's 150 degrees. So 150. And let me do something a little bit with that. I'm going to do that a little bit later, but we'll talk about that. So 360 times, I'm going to do this for both of them automatically, times, let's see, 10 pi. Whoops, I'm working ahead, guys. I'm sorry. So that's going to be 5 pi times 2. And then right here for the other part, right here for the area, it's 150 divided by 360 times pi 5 squared. So let's see, that's going to be 150 divided by 360. So that's simplified as 5/12. So we're going to do that for both of these both of these particular calculations. This one right here is 10 pi. And this one is going to be 25 pi. This has on this part right here, we have nothing to go ahead and cancel out with the 12 and the 25. So that's 125 divided by 12 pi. This one over here, we have a 2 and a 2 over here from the 10 and the 2 over here. So that right here is going to be 5 times 5 divided by, let me see, that's going to be 6 pi. And that's going to be basically 25 over 6 pi. And the other one is going to be 125 over 6 pi. And that's what the answers are into that. And that's basically it. I'm not going to do that particular problem. I'm going to have to put this as a second part because I'm running out of time. That's the problem with using this particular recorder. I'll go ahead and see you guys later. Well, I'm going to go ahead and put a part B.